This is the fifth video for section 6.1. Here we're just going to finishing all the inverse functions. So we still have cotangent, secant, and cosecants left. We're not going to go to each one of them very detailedly. But out of those three, cotangent graph, we can follow the tangent graph, which is we just using the original piece. Which is this one, from 0 to pi. And we just use the original 1 period and then transform to its inverse tangent graph. However, for the secant and cosecant graph, those are the reciprocal of the sine and cosine. So we don't really have any particular way, kind of process to get from the original secant or cosecant graph to its inverse graph. We actually also depending on its original tangent and sine and cosine graph, and then we just follow the same restriction for the sine inverse and cosine inverse, and then we just using them for the secant and cosecant function graph. So here I'm just going to quickly summarizing all six trig inverse functions. So for the inverse functions, if I'm talking about sine inverse, the domain for the sine inverse is going to be from -1 to 1. And then the range have two components. Number one is if you're talking about range in terms of interval, it's going to be between -pi/2 to pi/2. If you're talking about quadrant, we're talking about quadrant 1 and quadrant 4. If you're talking about y equal to cosine inverse, the domain is the same, -1 to 1. And then the range for the interval form is 0 to pi. In the quadrant version, is going to be quadrant 1 and quadrant 2. Tangent inverse, the domain is going to be everything from -infinity to positive infinity. The range in the interval notation is going to be -pi/2 to pi/2. Remember, -pi/2 and pi/2 also the asymptotes, so we cannot really including them. So we're using the wrong parentheses for excluding -pi/2 and pi/2. Quadrant versions is going to be the first quadrant and the fourth quadrant. For the cotangent one, the domain is going to be very similar to the tangent one. It's going to be from -infinity to positive infinity. The range, because of the cotangent graph, one period is from 0 to pi. So the range for the cotangent inverse is also going to be from 0 to pi, excluding 0 and pi because of the asymptotes. Quadrant is going to be quadrant 1 and quadrant 2. Y equal to secant inverse, which is the reciprocal of the cosine. The domain is going to be -infinity to -1, including, and 1 to positive infinity, including 1. The range for the interval form is going to be from 0 to pi/2, union pi/2 to pi. Because 0 and pi can be achieved, but pi/2 is going to be the asymptotes, so that's why we do not including the pi/2. Quadrant version is going to be quadrant 1 and quadrant 2. And then the last one, the cosecant inverse. The domain is going to be similar to the secant one. And then the range for the interval form is going to be including -pi/2 to 0, excluding 0. and 2 pi over 2. Same thing, 0 is the asymptotes. We're talking about quadrant, it's going to be quadrant 1 and quadrant 4. Okay, you can see it's very similar to the original, or not really the original, but it's corresponding sine inverse and then the corresponding cosine inverse. Okay, so here are the summaries, and then I'm just going to do a couple examples. So the first example is I will try to find the value for the the first one is theta equal to arc tangent of 1. According to the definitions, that tangent of theta equal to 1. So that tells me theta is going to be possibly equals to pi over 4 in quadrant 1, or 5 pi over 4 in quadrant 3. But since the range for tangent is going to be between negative pi over 2 to pi over 2, so we cannot have the 3 pi over 4. So pi over 4 is the answer. Okay, the second one we have is theta equal to secant inverse of 2. Okay, so secant inverse of 2, that means secant of theta equals to 2. If you're not sure about what is theta, give me secant of theta equal to 2. You can also convert it to cosine of theta equals to 1 over 2. Remember, secant and cosine are reciprocal of each other. So cosine of theta equal to 1/2. So cosine of theta equal to 1/2, that tells me theta is going to equals to pi over 3 in quadrant 1, 5 pi over 3 in quadrant 4. Both give me positive 1/2. Same thing for because of the range for cosine inverse is going to be between 0 and pi. So we cannot have 5 pi over 3. So the answer is going to be pi over 3. Okay, so we can also see another one, theta equals to cosecant inverse of negative square root 2. So that means cosecant of theta equal to negative square root of 2. Not really familiar with cosecant, so I can rewrite cosecant as sine of theta as negative 1 over square root 2 or square root 2 over 2. So negative square root 2 over 2 is more familiar. So that means theta can equals to negative, that means in quadrant 3 or quadrant 4. Negative square root 2 over 2 is going to the reference angle of pi over 4. So 5 pi over 4 or 7 pi over 4. However, when we're talking about the range for sine of inverse, it's going to be between negative pi over 2 and pi over 2. So both are not satisfied. So I have to thinking about other options. So I cannot go higher. I have to go lower to the kind of negative side. So in quadrant 4 is going to be negative pi over 4. In quadrant 3 is going to be negative 3 pi over 4. Okay, so out of those, we can see that even both quadrant 3, either positive or negative, are not satisfied. For quadrant 4, 7 pi over 4 is not satisfied. The only one we can have is negative pi over 4.